The last section of maths that we're going to be looking at is this section of the cumulative frequency ogives. And this is such a helpful way of displaying data because it takes grouped data and puts it in a way that we can actually read very accurate estimates of things like the median and the quartiles, even percentiles if we wanted to. So if we look at this, just a random cumulative frequency ogive here, the first thing that you need to know is that the cumulative frequency always goes on the y-axis. So these values here always represent cumulative frequency. So if ever you're asked to draw one, remember y-axis cumulative frequency. Then on the x-axis, we could put pretty much anything. So let's say we wanted to do something like time spent studying or time spent watching onboard tutor videos. So time spent watching videos. That's a very good thing to do in minutes. Okay. And here we have it. And now we can literally read from this ogive. Have a look at how cool this is. So I wanted to know how many people watched for at least 30 minutes. So we can then take a ruler and draw a line from the x-axis there where 30 minutes is represented, and then we can rotate that ruler and measure from the line, from that line to my axis there, and that would be the answer to my question. So I'd say this is probably about 13 people. So without having seen a single raw score, I can take this cumulative frequency ogive and I can determine some fairly accurate estimates of the data that was originally used to sketch it. So a very cool section to work with. Okay, something important to note is the one thing, we always want this to have a sort of an S shape. Okay, so it is a bit of a spread out S in this one. I suppose if I had made these increments closer together, we would have seen it more. But the minute that your graph starts to go up and down, you've probably used the frequency instead of the cumulative frequency, so be careful there. Okay, and the other thing that's important to remember is here, our ogive always gets anchored to the x-axis. So when we start drawing them for ourselves, that's going to be a point that we always need to plot. Let's try an example together. The owner of a tuck shop collects the following data about how much money learners spend on their lunch every day. So we've got the amount of money in rands and then the frequency. So in other words, 11 learners spend between 30 and 50. 17 learners spend between 50 and 70 rand, etc., etc., etc. Okay, draw a cumulative frequency ogive to represent this data. Now, I'm hoping you straight away look at this table and say, one, they've given us an extra column for a reason, and two, if we need to draw a cumulative frequency ogive, then we seem to be missing cumulative frequency. So that's going to be the place that we're going to start off here. Okay, how does cumulative frequency work? Well, it accumulates. So we start off with 11 people, and then those 11 are going to accumulate these additional 17. So 11 plus 17 takes us to 28. Then there's going to be an extra 9 added there, so it takes us up to 37. Then up to 45 when we add that 8, and finally to 50. Okay, and now when I plot, this is very important. In each instance, I'm going to plot the upper bound and the cumulative frequency. So the point I want to plot is going to be 50 and 11 there. Then I want to again plot upper bound, cumulative frequency. So my next one is going to be 70 and 28. So those coordinates are going to guide me. And then I want to be as accurate as possible. So most of the time we have an answer booklet or a grid that we can draw on. And so I've got a grid ready here so that we can answer this question, draw a cumulative frequency ogive to represent this data. Let's start off with a heading. These are good practices that I hope you developed already in grade 8. So cumulative frequency ogive of tuck money. That is not very well centered, but you get the point. Okay, we've got our heading. Then each of our axes needs a label also. Remember what I said to you? The y-axis is always cumulative frequency. So I need to get from 0 up to 50 on this axis here. So 0 up to 50. And I think if I go with each block being 2 units, so 2, 4, 6, 8, 10, that's going to work out for me. Okay, it's important to have the same number of jumps each time, because if it's not accurate, we can't actually read anything from it later on. Okay, so that's the cumulative frequency on the y-axis. Then we've got the amount in rands, which we're going to pop on the x-axis, and that needs to go from 30 all the way to 130. Now you may be saying, well, we're only plotting from 50, but do you remember what I said when we first met this whole ogive thing? We always need an anchor point. And so the anchor point is just this first lower bound, 30, and a 0. Okay, so when I plot, I'm going to plot like that. And so for that reason, I'm just going to keep my axis at 0, and my x-axis, I'm going to start it at 0, and then I'm going to go up in 20 so I can fit everything in, including that anchor point. Okay, so anchor point is at 30 and 0. There we go. Let's plot that. Now we're going to plot the other points, starting with 50 and 11. So 50 and 11 is going to be there. Then 70 and 28 is going to be there on that line. And we're going to go on like that. 90 and 37. So 90 and 37. There we go. Starting to see the S shape unfold here. 110 and 45. 110 and 45. And then finally 130 and 50. There we are. Okay, so there's our ogive. And then we're going to neatly, this is not a broken line graph, so be careful when you plot it. You don't want to have line segments. You want to try and get as neat a curve as possible. Okay, so that's our cumulative frequency ogive to represent this data. And now they say use your ogive to estimate the median of the data set. Okay, well, grade 11s, what do we know? We know that the median position is a half times n plus 1. So in other words, a half of n is 50. We saw that, 50 learners. So a half of 51, it takes us there to 25 and a half. Now we can't really have a 25 and a half person, so we're going to do the best we can to read there between 25 and 26, but realistically you're probably safer off saying it's the 26th value. 2, 4, 6. So I'm placing my ruler down and I'm drawing a neat straight line, and then from there I rotate the ruler around and I want to join that down to my axis. Okay, and there I'm now in a position to estimate, but it's an accurate estimate of this actual median. So the median is here, somewhere between 60 and 80. Now exactly halfway, 70 would be there, so it's less than 70. I would put the median at 67 there for this data set. Now let's try an example where they give us the ogive and we need to interpret it. Okay, so what are we looking at? We've got a cumulative frequency ogive alongside. Okay, we've got ice cream sales. Cumulative frequency, I think it's safe to assume this is the number of people buying ice cream, and then temperature in degrees Celsius. Okay, and to me it makes logical sense that the hotter the temperature, the more people will buy ice cream. Okay, but now we can actually put our statistics to the test to see if what I think is actually true. Okay, so question 1 says, how many customers visited the shop when the temperature was below 15 degrees Celsius? So they want to know, just like I do people actually eat ice cream when it is very cold? Okay, so we're going to pick up our ruler, and it's just important to know which axis to start on. Okay, so 15 degrees Celsius, that's the x-axis. So I'll find 15 degrees on my x-axis, and then I'll draw my line there. Okay, that's probably a little bit unnecessarily long. You just need to draw it until you hit the ogive. Okay, so there we go. And then, it's not wrong if you go over, but it's not necessary to draw such a long line. Then from there, I want to move and head towards my frequency side of things. Okay, and so now I can interpret that. That looks to me between 4 and 8, and it looks quite nicely in the middle there. So let's say that's 6 people. So how many people would still buy ice cream even when it's cold? I mean, if you love ice cream, you love ice cream. It's all of the people here below 6, okay? And so we'll just say 6 minus 0 equals 6 people. Now that might seem like an unnecessary calculation, okay, which is completely fine if you say that. But sometimes they'd say, how many customers would visit the shop when the temperature is between 15 and 20? And that's when you need to subtract. So this cumulative frequency minus that one, and so that's why I'm just in the habit of doing that. All right, now they want us to draw a box and whisker plot to represent this information. So what do we need in order to draw a box and whisker plot? We need a 5-number summary. So the 5-number summary is a minimum, quartile 1, quartile 2, quartile 3, and a maximum value. Okay, minimum and maximum, always easy. This axis here is cumulative frequency, so that's not going to tell me minimum or maximum. This axis here is the actual value we're working with. So degrees Celsius, our minimum is 0, our maximum is 35. So we can fill those in. And now we want to work out the quartiles using this ogive. So this is a great question. So quartile 1, let's figure out what position we are looking in for each of these bits of information. Okay, how many customers are we talking about? We are talking about 28 customers. Okay, it's always the last, your highest cumulative frequency. So this point here is 35 and 28. All right, so to get the position, I'm going to say, well, a quarter times by 29, n plus 1, okay? 2 quarters times by 29, and 3 quarters times by 29. That's in each instance going to give me the position of that quartile. Okay, so quarter, 1 over 4 times 29. Okay, that gives me 7,25, and I just repeat the process to get all of those positions. All right, why did I do that? It's because I want to read those quartiles off of this ogive. Now I'm going to work out what these quartiles are. So 7,25, okay, 4, 7 would probably be about there. I can draw my line, and then I'll rotate the ruler around. So there I can see, well, this is between 15 and 20, and I'd say it's not quite halfway, so let's say quartile 1 is 17. And then in a very similar fashion, we can measure quartile 2 by joining 14,5 there and down to the x-axis, which takes us to about 23. And then finally, that last one there, the quartile 3 takes us to about 28, let's say. Okay, I should have given many more grid lines here, then it would have been easy to read, but you get the general idea. Okay, once we've got that down, then we need to plot our box and whisker. Okay, and our box and whisker needs to start with a number line. So my number line is labeled from minimum to maximum, and now I plot this 5-number summary. So 0 is my minimum. 35 there is the maximum. And I've got my quartiles at 17. So I'd say that's about there. At 23 and 28. So all that's left to do now is draw accurately the whiskers and then get these boxes drawn nice and neatly. So there we go. I'm going to finish all my lines and make sure that it is as accurate as possible. Okay, grade 11. So one final question for you. What is the skewness of this box and whisker plot that we've just drawn? Well, have a look at this long tail here extending to the left. This box is also wider than this box. So this is definitely negatively skewed or skewed to the left. Okay, which means the same thing. And that makes perfect sense because the colder it is, the fewer people will buy ice cream, and the hotter it is, the more clustered together our data will be because more and more people will be buying ice cream. So there we have a super practical application of how the cumulative frequency ogive can help us to interpret data.